Alright, I think we're live. Hello all, hello world. This is day 58 of studying compilers every day until I land a compiler role. I'm really damn tired right now, so we'll see how the stream goes. But yeah, we're gonna do the LeetCode daily, cause why wouldn't I do the LeetCode daily? And then the other thing is, we're kind of at like this weird spot where there's nothing that like immediately jumps out as something that would be fun for me to implement. In terms of the middle end, we've like run out of meaningful optimizations given the current state of the code. The front end stuff is all like low-key kind of annoying, and all of the back end stuff I still need to plan out more. So I think for now, I think the plan is to add more operators to our pile and then finally do proper expression parsing. I think today I might limit it to just adding more operators because I'm quite tired though, so we'll see what happens. Yeah, this is like the operator precedence. I'm not sure how much of this I'm gonna be including. Yeah, we'll see what ends up happening, at least. Sounds like the perfect time to rewrite the whole thing in Haskell? Hell no. I don't know, I want to learn Haskell eventually, but may as well. I might hold off on that one, unfortunately. Okay, let's see. Let's keep the streak going. What are we cooking with these? Is this just... I thought this was potion week. I guess it's just magic week. We're taking the maximum energy from the mystic dungeon. Okay. And magicians are standing in a line. Each magician has an attribute. What the hell? Absorbing energy from I. Okay. Go out of bounds. Teleport with K jumps to reach the end of the sequence. Okay. Okay, that's really funny actually. Sure. Is this just DP? I feel like there's gotta be a better way to do this though. K jumps is the... Oh, wait, no. Wait. Instantly transport to magician I plus K. Okay. So K is 3 here, so from magician 1. K is 3, 1, 2, 3. So we go to here. Okay. Okay, well, what is this? I mean, is this just like a O of like, or is there like a sliding window thing even, I feel like? Huh. Yeah, is this just O of N, I guess? That's really funny. Okay, let me just... Okay, prefix sum. I feel like I'm not seeing it. Okay, well... Well, this is not helpful. Okay, so... Sure, okay. I guess this is like DP in a prefix sum anyway, so I guess that kind of makes sense. Yeah, let's I guess, let's just go from energy. So energy size is less than or greater than equal to 0, I minus minus. And then we can keep a running sum at least. And we can just do this in linear time, I guess. Okay, and then this we can set as like, I don't know, I guess energy back, I guess. That makes reasonable sense. Okay, so we have this. This should actually be energy size +1. Or -1 actually, so we're in bounds. And then we just set the current to, we can just add the I plus k thing to it. Okay, so if I plus k is less than energy size, so if it's in bounds, then energy at I equals, we can just add energy at I plus k. Yeah, and then we'll always reach the greater one before. So then res is now the max of res and energy at I. We can return res, right? Is this all this medium is? Am I? Okay, well. Okay, so what is the fast way of doing this? What the hell? I guess we could save that read, huh? Yeah, that's the minimum. So we can -1000 this, right? And this should be faster by a little bit. Nope. Same. Okay, it's less fast actually even. Okay, well, yeah. Anyway, that's the daily. I think that's straightforward enough. That was a cute problem. Okay. So yeah, the big two things are adding operators and doing proper expression parsing. So I'm gonna take a look at this one first. So if we look at what we have so far, we have addition, subtraction, we have multiplication, and we have bitwise AND. I'd ideally like to implement at least some of these. I'm not sure how many of these binary ones I will include, but or binary? What am I saying? Not binary. Relational. I guess I could probably just implement them without much hassle though, so I could probably do it. So let's get a list going at least. Yeah. So plus, minus, times. I guess we could add division. That might make a mess, but or at least that might make a mess at the assembly level, but I think it's worth it. We could probably add mod at least. I think the other thing we could look at is like what's even supported in x86 natively. Don't question what I was doing there. Yeah, let's get the little cheat sheet. Hopefully there's a nice one. Okay. This is a lot. Okay. Yeah, we got 2,000 pages of straight instructions. Is there anything anything easy to find here? Oh god. Compiler intrinsics. Oh god. Okay. we're gonna have a good time. So is there a mod? Is the first question here. Okay, what actually is like half of this? Like, come on. VCV TTPS 2. Well, yeah, I'm having a good time. This is just. Oh, sorry about that. Yeah, there's just like so much crazy stuff in here, and it's pretty funny, at least to me. Some of it. Close your eyes for a second. Okay. What else is there? It's like these are some like crazy names. Like I'm very happy to call. PH add W. Or like PMAXSB. That's what my parents think when I say when I say those computer. Yeah, exactly. That's kind of the vibe. Like, what is half of this stuff? Perform 2 rounds of SHA-256 operation. What are we doing? Yeah, maybe ARM would have been smart, huh? In hindsight. Let me reset my camera real quick. Okay, we're not blurry anymore. Like, what the fuck? What are we doing? vget SD, like, yeah, I'm not gonna get this stuff, I can't lie. If it wasn't obvious, I'm not gonna be implementing stuff for the backend for all of this because there's a lot of stuff here. So yeah. Is there, let's see. Is there an easier list anywhere? Maybe one of these university slides. I should probably read this just on my own. This seems very nice. Okay, there's more system stuff. What else is there? Immediate. Sure. Okay, none of this is helpful to me. Oh, look, something actually readable now. Okay, we got registers. I will probably be using some of these registers. Oh, I need to worry about calling convention when I generate code. That's gonna be fun. Okay. Interesting file here. Inc, dec, negative, not. So I think we should try and map these onto the operators here, at least, to some degree. So this is add. This is sub. This is, I guess, iml. Actually, no, we just care about, yeah, these are fine. Okay, and division is its own little mess, so we might actually skip that for now. Maybe mod might be annoying. Bitwise XOR. Do we have an operator? Oh yeah, we do. I forgot about that. Okay. So let's do that. XOR. Let's do all the easy ones here. I think all of these should be pretty easy. So with that, we have or we have and. So this makes like a little arrow, which I think is funny. Okay, so those are the easy ones here. I think we should probably implement LEA at least, but that's like a later issue. We can add some unary operators as well, I think. So we have plus plus, minus minus. We'll only do postfix, I think. Yeah, because that makes everything a little bit less annoying. I don't want to have to worry about prefix, at least. Yeah, we'll just do it like that. Flashbanged by the page. Is there a way that like this PDF viewer can be dark? I would like to be able to see. Okay, I guess there's not. Okay. Yeah, okay. That's unlucky. Okay. Yeah, so we have that. I think we could, by extension, through all of these, we can implement plus equals and minus equals. I think the shifts also might be reasonable. There might be some weird like calling convention things with it though. Are adding byte-offs? Just more operations in general, I guess. So I guess yes. Yes, I guess, yeah. Division is scary. Division is scary to me. I don't want to do this. We can worry about that later. We can worry about condition codes later. The rest of this doesn't affect much, I think. Like yes, I can read that. Yes. Convert word to long word, I guess. Convert long word to quad word. Nobody wants to do this, just think of a job security. That's true, that's true. Now that you word it that way, I feel a lot better about this actually. Are you planning to or already have implemented typecasting? I tried to, and then I made a mess and I was like, I'm just not gonna deal with types for now. Yeah, so unless I want to do like a complete parser rewrite, which I guess I'm already doing half of now. But maybe that's like a distant future plan, at least. I don't particularly feel like doing it in the short term. Maybe that's like a 1 year out sort of task. Yeah, handling types isn't really the focus of anything. Type systems are just low-key kind of difficult. Yeah, I think I mostly care about the optimizations, and unfortunately that means, or fortunately that means I get to stay in middle end land for most of it. Unfortunately, to actually test the effectiveness of my to test the effectiveness of my optimizations, I'm gonna need to generate a backend. And I'm also gonna need at least some degree of verbose front-end stuff to make interesting operations occur. Because right now, we don't really have a lot of stuff. So like constant fold and like, or mem2reg plus constant folding kind of does everything for us already. So yeah, we're just gonna need to add more stuff, which is like fine. I just need to deal with that at least. Yeah, so we can use those. These are like binary assignment, I guess. Yeah. Okay. What am I doing? let's add more unary operators. We want negate, so I guess like that. What is the difference? Are you adding security mitigations? I'm not worrying about it. That actually could be something interesting. I need to like look into it more though. That's not the primary focus for the time being, at least. What is the difference between these? Okay, so I think this is the one we care about, or no, I lied. This is not. This is not. Okay, and negate is literally negate. Okay. Whoops, I forgot. I forgot that's the thing. Oh yeah, speaking of negate, I recently learned that unary plus is an operator, which seems a little bit pointless. It's just like why, I guess. I asked one of my really cracked friends why unary plus exists. The only answer I got was like, the only answer I got was like just to cast things into numbers, which is really funny. I thought you just specified header in the binary. Okay. Let's see. Is there something I can look up to look into that more, or is there like a specific term of art for that at least? Okay, let's take a snippet of that. Unary plus the cast lambdas to function. What the hell? Yeah, what are we doing? Like, fair enough, but also what are we doing? Okay, this highlighter works, I guess. Yeah, so let's highlight the ones we're doing. Woo, highlighter. Okay. What the hell? Okay, anyway. Okay, so we want postfix increment. I want arrays eventually, but we need to add arrays. Use that once? I see. That's pretty funny. But also like, I don't like why? Like actually why? Like I assume you have like a real reason, but also like why? Yeah, we can add those. Those are easy. We can add logical and bitwise not. Yeah, we can keep going through this. Interesting, it's called indirection. Like, I guess it makes sense. I've always heard deref, but okay. We can definitely do these two. How does modulo lower actually? I'm curious now. God bolt. Let's make this big again. Also, don't worry about what I was doing here. Don't worry about it too much. Okay. 5. J equals I mod 2, I guess. What is this? What is this lower to? Rem. idiv. Ugh. Oh, I forgot to semicolon. The function took a void pointer? Ah. Yeah, I mean, fair enough. Okay, so where's the multiplication here? Oh, it's just folded. Okay. Okay, so then now we have a mult, right? Okay. Yeah, so we have imul and then idiv, I guess. Okay. I guess we could add division then. We could kind of, we just have to like handle it interestingly, at least. Where is idiv? Yeah, okay. We have imul q, idiv q. Where is just idiv? Okay, well, at least we know it exists, so we can do something with that. So how is mod handled again? I did not pay attention to that. CDQ. Huh? What is CDQ? x86 CDQ. x86 modulo. How to do modulo? This is a good question. Never use div, yeah, that makes sense. You over here using cheat sheets, really? Yeah. I mean, that's kind of just like how to learn this stuff, I guess. Oh my god, this my brain is like expanding right now because I don't think in assembly, at least, which is really strange. One thing I'll never understand is how people understand that. I'm not gonna try and read that out loud. And don't self-fault. Yeah. Yeah, I'm not wait, I actually have a relevant article for this actually. C circle rule. Or C operator circle rule. Spiral rule, yeah. If you haven't heard of this, oh god, okay, 1 second. Sorry about that. Yeah. So there's this nice little thing where you can figure out what things are in this sort of spiral shape, I guess. I'm just gonna put this in chat. Let me know if it doesn't send, but it's there if you want to give it a read. But yeah, you can kind of read this in a spiral and it like kind of makes sense. Yeah, that's pretty neat. It makes me happy. I'm actually gonna keep this in some dark corner somewhere. Actually, I'm just gonna put it in the Discord. This is really useful. Yeah, it's in the coding channel if you want a permanent copy of that. Yeah, anyway. Where was I? Okay, modulo. I have a question, what's up? Why don't you use Opera? Because Firefox is fine. Okay. So div, idiv gives the remainder, which can be negative. Always use XOR before unsigned. Jesus Christ. Okay, so we care about signed division, so we want CDQ. That makes sense. Yeah, okay. Okay. You know what? I'm not even gonna... I think the solution to this for now, at least, before my head explodes, is just to, like, not do modulo. So... Can Firefox link two tabs together as a split screen view? No, it cannot. But also, like, I could also just split screen like a normal person, I guess. I don't know. It feels like, yes, that is a functionality I miss, but also, like, it's not that big of a deal, I think. We can process those. We could add shift, I think. Those should be pretty easy. Let's see the pile here. Ah, full blind. Okay. Can I turn Dark Reader on PDF? No. Okay. God damn it. Okay. Actually, I think I have another x86 cheat sheet somewhere. Let me pull this. It's from my Intro to Systems class. Where does this live again? When did I take this class again? Okay, I found it. Files. Reference documents. Okay, lock in. There's a Unix guide. That's not what I'm looking for. There's a GDB guide. There's just a straight up C99 spec doc. It's 500 pages long. I guess that would do the reading for me. x86 cheat sheet, okay. This is the same one as this, okay. God damn it. Okay, let me just save this real quick. We're not gonna leak the rest of this. Okay. Okay. Where are the shifts again? SAR, SAL, SHR. Okay, I think we should add those at least. We can figure out which one to use when the time comes. We can definitely support all of these, I think. We just need to be a little bit funky with how the code is generated. We can do equals equals and not equals as well. Bitwise AND we can do, bitwise XOR we can do, bitwise OR we can do. I don't know if we want to do logical AND, but I think we could get rid of some of these for now at least. We can add logical ones later. Bitwise AND, bitwise XOR, bitwise OR. Ternary. We can add these two, we can add these two. We can add these definitely. We can definitely do these. We can do assignment, of course. Yeah, okay. I think that's a pretty good list, at least. Let me put this somewhere. I don't know where to put it. Let's put it in my brain rot pile. There we go. Okay. So we have this list. Okay. So I guess with this list we can start doing things with our life. Yeah, okay. So let's... Am I in a branch right now? Let's make a branch. Let's do expr parsing. Okay. Uh-oh. pull again real quick. X for parsing. How does this work? Okay, this is good. See, has more operators and keywords? Wow. I guess I could kind of see that. That's also like quite crazy though. Okay, how do we even support all of these? I guess we could just work from the parser down. We definitely need to represent more of these in here at least. Or actually, we'd be doing prefix, right? Huh. Maybe I just don't do those, honestly. Yeah, let's save the headache of that. Because then we have to like think about more things. And I don't want to think about more things right now. Okay. Also, I think we could just do logical, right? Because those just turn into 1 and 0. Yeah, we can add those and then these as well. That's actually, I think that's a pretty comprehensive set, at least barring like, you know, things that require memory. But yeah, those are our future priority. How to get short circuiting right? Yeah. Oh fuck, you're right. Should be fine, surely. We can just parse the thing, and then we can like. How does that lower actually? Yeah, I don't know. We'll figure it out as we go, at least. Okay, let's go to the parser. Let's start cleaning things up. Okay. So we want to change this pile at least. I would like to make an expr struct at least, I think. Also, this is very tragic, by the way. We very much do not have types anymore, but that's okay. Handle an AST form, but it's a short algorithm. I see. Yeah, I think I'll run into it as I go. Okay, so let's do struct expr. What is an expression? Because I kind of have to like force encode operator precedence here at least. So I guess the some secret mitigations you can just set a flag in the binary. Interesting. Okay, I'll look into that more at some other point. In terms of what an expr is, I think we can just do a big OR across these and then like one level down, and we can just like kind of do levels with this at least. Yes, we can do like equals comes last because all of the other ones have an equal in it. This is going to make a mess, I fear. So we need more keywords. Or not keywords, just like symbols. Because I don't want to write peg till 1 so frequently. We have plus, minus, asterisk, ampersand. I think we need a slash, right? Yeah, we're doing division. Let's just split screen again. Plus, minus, we need an exclamation. Or bang, I guess we call it. We love bang. Okay. We have that one. We have not, I guess. Or tilde. Okay, so we have star. Asterisk was stupid. I should just call it star. We need slash. We have plus, we have minus. We have... Do we have greater than? How do I prevent a collision here? We can just do this. Class. We have an equals. We have two equals. We have bang still, that's fine. We have equals still, that's fine. And we need a caret. How's it spelled? Is it just one R? Caret? If that's how it's spelled. Okay. Caret. Caret. It's the caret. Okay. We need pipe. Those are handled and everything else here is handled. Okay. I'm not looking forward to any of this, Chief. Okay, let's get this started. And we should probably move this up for continuity. Okay, I think we could also move this up. Crazy a library like this can even exist? Yeah. Honestly, just parser generators are so cool in general, I think. Yeah, templates are... Actually, yeah, let me just generalize that a little more. Templates in general are crazy. Like, we made them to avoid the mess with, like, C macros, and then we kind of just made the problem worse. Yeah. Yeah, that's how it is. This reminds me, actually, the other thing I want to implement at some point, do I have this in here? Oh, I should have a miscellaneous section. Template-based dynamic cast. Because I want to do something similar to what LLVM does for dynamic cast. In a way that's like not incredibly slow, at least. I think that would be pretty neat. Okay. So we have this whole pile. Where do we go here? Yeah, let's change this to expression. And we can also rewrite the way we handle a lot of things further down as well, which is nice. Okay. I think, okay, so the problem down here is this stuff is kind of subsumed, I think, by a lot of this. Also call assign also gets subsumed. Yeah, so we're gonna have to rewrite a lot of this. I think the point I'm gonna write it on is just like expression alone is a valid instruction, but I'm also gonna separate out assign instruction and yeah, I'm gonna separate out assign instruction and then like the assignment by like this pile down here, I think. Oh god. Okay. Yeah. I think that's a pretty reasonable way to separate it out, at least. Yeah, let's give that a start at least. Or maybe I could just make these like, I could just directly convert these into something else. That might also just be easier with like my second, like desugared AST at least. That seems more universalizable, so I might do it that way. Also, operator parsing precedence is gonna be a mess here, I think. Because a pectoral roll might fire early, which I'm not excited to deal with, but I guess that's also why I'm doing all of this, so like, fair enough. Okay, so we want struct. Maybe we go the other way, actually. So we have number, we have value. Or identifier and number, I think those are good. Unary and plus and minus are operators, so we can take them out of here actually, I think. We don't need the sequence anymore, I think. Yeah, so we can do that. Oh boy, okay. Okay, so we have those. The next layer up here. Yeah, I could just like put precedences on these, I think. Where's this live? Refer to operator precedence. Okay, perfect. Yeah, okay. Let's separate it like that, I think. Okay. Yeah, let's do it like this. We don't have a 1 here, so I can just empty line that, I think. So we can do precedence 2 here. Okay. So then struct unary. What do we even call this? Is this okay? So this is right to left associative. That's annoying. Guess my second nightmare that I uncovered today. What's up? What happened? Unary plus minus. This is great. This is structured or. This is a plus minus, I guess. Oh wait, we need to apply this to a. Oh my god, do we need to like forward declare things actually? Yeah, because this parses right to left, so we'd also want struct expr2, I guess we could call it that. So value is like the baseline here. $14K errors. Say more. What happened? We need not here. What the hell am I doing here? I don't want to talk about it? Fair enough. Seems like a mess. Let's need this. Actually, we need to parse this differently. So we need pectoral sequence of this, and then that's the last time I let a friend try to help in C#. Yeah, fair enough. Yeah, that's how it be sometimes. Okay, so then here we need expr 2, I think, right? Okay, that seems valid. Unary not. How much do we separate this out? Do you have a favorite type of lo-fi music? Not really, to be honest. Let's actually separate out Unary plus and Unary minus to make this a little cleaner. So we need plus and then expr 2. I hope I'm not making too much of a mess here. That would really suck if I were. Minus. So we want logical not here. You should try to make your own error handler? That's in the books. I don't have like that as an immediate priority, but it's definitely something that would be interesting, I think. What do diagnostics look like in this library? I'm gonna be honest, it's kind of a mess, but that's kind of just the header only experience. I feel like most of the errors from this library at least is just like whatchamacallit. Most of it's just like logical errors, so it isn't really like caught by anything. There's a lot of like really finicky silent errors, like if you there's like certain combinations of peg operators that I think just infinite recurse into 0. Which is kind of funny, but yeah. Useful in general to do that in the first place in case issues arise. To some degree, yes, but also I feel like if it's just like C code, I can kind of just run it through a like real C compiler, and we can see what goes wrong with that at least. Yeah, I mean it's. I don't think I'm going to be like developing the next large program with this compiler, so yeah. Bang, that's what we call it. We want bitwise not. Maybe I should shorten some of these, but I think expressiveness here works to my advantage. Okay, so we have all of those, and then expr 2. And this is a pegtool SOR unary plus unary minus unary logical not unary bitwise not, or a or just a straight up value, I think. Right? I think I'm doing this correctly. Yeah, we'll figure out precedence 1 eventually, but I don't think I need to include it explicitly right now, so I think that's fine. Array subscript will be something I need eventually. I don't think there's a chance for this to infinite, right? Yeah, because this should just like go all the way down in parse order at least. Are you parsing x plus y times z correctly? I need to get to that point first. I'm trying to build the sort of parsing structure up from the ground up. Okay, so we want struct expr 3. So this one will just be multiplication and division. Left to right associativity. So then, okay, so we want okay. Yeah, so we definitely need to like do this recursively to some degree. So struct multiplication multiply. Let's be less verbose. This is a sequence. So we have a, this is left to right, so the leftmost should be an expr 3, and then we want a asterisk. Oh, I might need white space, I just realized. Oh. Okay, I'll worry about that in a second. Okay, expr 3, asterisk, and then expr 2, I guess. Maybe value should come first here, it just occurred to me. Yeah, because we want to go down first, and then we can work on top of that. Yeah, this looks right. Do that. Divide. It's a slash. And then expr 3 is a structured or structured sequential OR? I think it's sequential OR. So it's either an expr 2 or it's a multiply, or it's a divide. I hope I'm doing this correctly. I'm definitely missing the white space, I think, but that's something I need to test real quick. Does it matter for the unary ones? So if I do tilde space 1, okay, that parses. If I bang 1, it's a 0. That's a 0, then that's a something. If I just make that a mess, it is a 0. Okay. Okay, so then plus like this, and a minus like this. Oh, wait, this is gonna make a mess. I just realized. Yeah, because this, all of a sudden, how do we even parse this, right? Okay. Yeah, this is the thing I'm concerned about with unary plus and minus at least. Because how does this get parsed at least? Because it would read the 5, it would read the plus. Or even just like something like 5 minus that. So it'd read the 5, it would read this. It would parse this as one value, which is not what we want. Yeah, that's the problem that we're running into with this here. Yeah, let's... Yeah, okay. So we do need an ignorable here. Okay, this makes things a little bit messier, but yeah, I'm scared of how this is going to parse at least, if we're going bottom up like this. That's actually a really big problem, now that I think about it. Yeah, how do I properly handle that? I think what I'll do is I'm gonna implement a couple more levels, and then I'm gonna throw it at ChatGPT and see what it says. Because I genuinely don't know how to structure it. I'm actually like quite at a loss. Yeah, okay. Typo example? Let's see. Or at least I know for like for instructions here, I have this like apply if match thing. Yeah, but I don't think that really resolves the issue here at least, because that's like a how about you just do a loop for the binary operators and then parse expert would handle unaries? Oh, I guess that makes sense. Yeah, I don't know. We'll see. We'll see what ends up happening here. I think I will just throw it at ChatGPT. I think that will be the best explanation I'll get anywhere at least. I don't think I can word this example in a way that I can like find it in Pectool docs at least. I hate the way this extends, but this is fine. Oh, wait. Wait, this is wrong. Whoops. Okay. Yeah, okay, so that's good. Now we get to do 4. This is where plus minus comes in, for real. Okay. So we have add. So this is a copy from above. Then X for 4. This is left to right as well, so we can do it like that. This is a plus. And this is an X for 3. Okay. Sub, I guess. Man, I need to sort out my naming conventions here. I don't think the verbosity is bad, but it's definitely getting to me a little bit. Yeah, cause this parses bottom up, I think. Because the other thing I'm thinking I could do is just like wrap everything with like apply if match. This thing, but it's just like really slow, I guess, and really expensive. I still need to keep this for a second at least. Okay, let's give this a chat. Let's see what it happens. Let's see what it does with it. How do I avoid unary plus minus eating the plus minus in something like 5 plus 10, or just like 5 plus 10, yeah. Hectol. Okay. Beginning of a what? Oh, I guess that makes sense. Yeah, that makes a lot of sense. What? Okay, so I guess it's like own layer, I guess. But that's what we're doing, right? Does this mean, wait, does this mean that like, does this mean that this is like valid code? Oh, it's not. Wait. Oh, it's not because this is a plus plus. That's really funny. Yeah, okay. So then does this mean like, I don't know, I guess this would be valid, but yeah, okay. That's really funny. Anyway. We have that. Unary. Huh. Does this solve the problem? Wait, what? Oh, wait, yeah, okay. I see. Oh yeah, I need to add parentheses, I just realized. Oh, fuck. Are there really companies that have compiler rules? Yes, there's a decent handful at least. Some of them have like proprietary compilers they're working on. Some of them, actually just all of them have proprietary compilers that they're working on. Like Apple has its Swift compiler, NVIDIA has like a CUDA compiler, and then like various companies are like working on their own LLVM-based toolchains as well. So there's definitely some demand for it at least, and I think it's only gonna grow. Okay, so we do need parentheses. That is what I forgot about. Yeah, we can add parentheses. Alright, is it this? Compound literal. Whoa. What do I even do with this? I mean, I could also just gamble and pray that this is correct at least. We could see if it's correct and try it out the hard way, at least. It's not really appealing though. How is assignment parsed actually? So it was like a equals 1 equals int I equals 0 equals I equals 1? Is this valid? Okay, it's not valid because I forgot a semicolon. But this is valid, which does not bring me joy. Okay, well that makes a mess out of things. Left operand must be unary level 2 non-cast. Okay. Okay, so then oh, wait a second. Wait. Am I just tripping? Is this fine? Okay, so it's just my naming. My names are off because of this thing. It should be fine though, right? I don't know, we'll give it a try. I think that might be the only way to find out if this is correct. I can't seem to wrap my head around it, at least for some reason. let's keep going. 5 is bit shift. We can skip that for now, actually. We'll add the rest of these in later. Okay, let's do that at least. So right now we have these added. I want to just comment these out for now because I haven't implemented them yet. We definitely have these two. We definitely have these. Yeah, let's just do the ones we have for now, so I don't have to add a lot yet, and then we can extend this as we go, and I think it'll be a little bit easier. We can just write tests as we go as well. Okay, so struct bit and yeah, we can make this bitwise. So this is a sequence. This is also left to right, so we want expr 8, bitwise, and expr 4, I guess. That's kind of funny. Do you do compiler work only on stream? No. Although I guess the stuff I do on this project is mostly on stream. I do a little bit of this stuff off stream, but very little. The big pile that I do off stream is just like reading stuff and formal research work for like my master's thesis. So yeah, that's all like compiler related as well, at least. So we have expr 8. This is a pactal sequential OR. This is an expr 4 or a bitwise, and okay. This means we can get rid of binary off, I think. Type is fine. We definitely need to extend all this later. This is broken now, but that's fine. Assignment is a little bit scary to me. Do I even want to handle the like assignment chaining case? That seems very unpleasant, at least. Like this sort of code. Ignore this rule. Okay. That's really funny. Yeah, I'll add parentheses eventually. My concern is if there is only one plus, it will get eaten up. Or is pectoral top down or bottom up? If it's top down, then all of our problems are solved. Oh wait, no, yeah, this should be fine. Yeah, okay, that makes sense. So it tries to match add. Oh wait, this makes me wonder. Wait. Okay, so that is valid. That's really funny. Cause like, why? Okay, so we first step through 3 for the 5. Is peg tool top down or bottom up? I swear it was bottom up, but I could be tripping. Peg formalism. Templates. That doesn't help me whatsoever. What the okay. Aha! Slides. Grammar, actions. Here only. Bottom up, okay. Our actions are invoked bottom up. I don't know, I'll look through this later. We'll just test this. Okay. I think I will simplify the range of programs that we can use this with, even if it's technically incorrect. Because that will save so much headache, and I don't think I want to support programs that work with 1 equals A equals B, or A equals B equals C. Like, cause like, why would you write that code? I'm sure there's a reason, but also like, why? Okay, so let's do instruction equals operator return void. I see. That's smart. Yeah, that's good. I feel like I could probably set it as a special case at least. I think declaration I could keep as is. I don't think I need to do anything crazy with that because there's a type attached to that, so we can keep that. I think we can keep assigned value, but we replace value. We can just change that to declaration assign. We can replace value with, let's just make an expert type here. I think that works, right? And then we can just go down here and fix our mess. Yeah, so declaration equals that. Yeah, assign I think makes sense. We can identifier equals, and then we can change this out to expr. We don't need this anymore. We can change this to expr. Call still is the same. Call assign I think is. Oh. Wait. Wait a second. Wait, a call is it's an operation. Alright, what happens if I set something to a void type then? Oh wait, no, we don't have voids. This is fine. This is perfect. Okay. So that is actually a precedence 1 operation, which I guess saves a little bit of mess for me at least. What's good, Zian? Function call. Okay. Struct expr1. So we can finally make that less awful. Yeah, we can steal some of the stuff down here actually. This will simplify things a lot actually, which is very nice. Okay, so identifier. Yeah, we can just steal this list, I think. Right? Yeah. So it's a sequence of, paste this in here. Yeah, that's really funny. It's an identifier, ignorable, and then a parens. Parameter list once I get there. Yeah. So then expr1 is a pectal SOR. We can collapse some of these levels down, I think, but I think this matters to some degree. God damn it. Yeah, and then we can handle like special cases in some other way at least. Okay. So SOR, this is a this is either a value or an expr1 call. Almost recursively defined it by accident. What's good? How's it going? Welcome to the stream. I am in parser hell right now, so yeah. I need motivation and time management like yours. I have a project complete, but I keep delaying it. Yeah, I think the biggest, if you want advice for this, I think the biggest thing is just like, if you set aside time, just like any amount of time for it every day, I think just like grains of sand make a heap. So like, some days it's like really difficult for me to like get myself to work on things. Like I didn't want to start with this parser stuff today, but at least I feel like the hardest part really is just getting started, especially if your project is something you like really care about. So yeah, hopefully that inspires you to I guess work on things a little as well. Luck out unit compilers. I took the compilers class at my school on a dare because it was a really hard class, and one of my friends was like, I'll take it if you take it. So then I took it, and then it turns out I really enjoyed it. So I reached out to the prof after, and I did a little bit of compilers research, and now I'm here, I guess, just doing more of the same thing. Except I do it on YouTube now instead, I guess. Or I do it on YouTube on top of doing research now. Yeah, I can add a highlight here, I guess, technically. Okay. I think this is fine for now, at least. Yeah, we need to structure calls like that, so I think that's fine. And these are left to right associative, so we do left first. Wait, so does this, wait, if this is left to right associative, does that mean that like, let me write some really cursed code real quick. So you have that, and then, so we can use the bracket operator. So return like I at 5. So we all know this works if I add a semicolon. I think some of you might know that instead of I5 we can do 5 bracket I, which also works. So now does this imply that we can do this? Or wait, no. We want postfix, so I++ bracket 5. It's really struggling. Okay, it's not struggling. Okay, so what if we do 5++ bracket I? Oh, okay. Well, that was worth a shot. Like, yeah, that one's pretty funny. Starting saying on it's tough, but that's the life we have to live. Yeah, of course. Yeah, I guess part of the goal of these streams as well is just to encourage more people to, I guess, work on their own personal projects, because it's a lot easier to do when you're watching someone else do it and you're like, damn, I should be doing it as well. So, yeah. Yeah, I think this is reasonable for what this can be. I think here we invert the order here, right? We either do that or a value. Here I think we could also do something similar. Oh yeah, this actually solves all my problems, I think. Yeah, this sequencing is wrong. Because if we want it to go down a level if none of these work, I think. Right, is that how SOR works again? That doesn't help me. So we can add subtract, or we can expert 3. I'm software in CS and math, and I'm still trying to find what I'm interested in. I noticed my projects were just for a resume. That makes sense. I feel like that's kind of just an inevitable effect of like first 2 years, because like at the end of the day, like you're trying to get employed, right? So like, I think that's fair enough. I will say if like, I guess making projects strictly for the resume doesn't preclude you from, I guess, using those projects as a way to explore what you're interested in as well. So like, if you wanted to like make a game engine, go for it. If you want to make a compiler like I am, go for it. If you want to just make an interpreter, which I think is the project everyone should do, feel free to go for that. You can definitely diversify on that end if you're like very much not sure what you want to focus on. Hell, even like throw like some basic ML projects on there, like throw PyTorch at something, see what happens. Like, PyTorch is great. Let's learn anti-cheat once? Yeah. Memory and OS, yeah, exactly. I feel like every single project, there's something to learn. Unless you were like writing the 5th CRUD app on your resume, then in that case, then like, maybe the returns are a little bit diminishing. But even still, you can definitely find ways to, I guess, diversify within that. Okay, what's wrong here? We don't have these anymore. Oh god. Okay, so scope, while, if else, if. Return is still fine, we don't have these two anymore. This we renamed to declaration assign, I think. This is fine, assign is fine, and then this doesn't exist anymore. Oh, Jesus. Okay. This is just assign now, right? Yeah, okay. Okay, that's cool. Alright. This is a mess. This really is a mess. I hate this. There's one other thing that I'm missing here, which is title, apply, if match. We need to be able to just parse, we just need to be able to parse a straight up expression as well. That's the last case we're missing. And I think after this we should be functional, at least. And I guess proof that we can just directly throw an expression here is like, let's clean up this mess real quick. We can just throw a 1 in here and it works, which I think is really funny. It does nothing, but we might want to make it a little bit more interesting though, because it needs a semicolon. Yeah, so we can do that. Title sequence. Throw a space there. Yeah. So this is a expr, ignorable, and then a semicolon. Yeah, so instead of expr down here then, we just need instruction expr. Yeah, the declarations definitely take precedence over the assignment. Yeah, these are all just like decreasing parse scope, if that makes sense. Have you ever thought of making teaching style videos about compilers? Yes, actually. That's something I want to do eventually at some point because I just think it's really cool. And there's a couple of videos that exist, but they're all kind of limited in scope at least. So maybe I'll make a course at some point, but yeah. That's a pretty ambitious goal in the future. So we'll see what I end up doing, but yeah. With that being said, I think like the big thing that's like holding me back from that is like straight up just the amount of time I have. It's like between school and streaming and all the other various extracurriculars I have, I just don't really have a lot of time, unfortunately. So yeah, that's kind of how the cookie crumbles, I guess. Okay, we need to change this parse tokens thing, I think. Yeah, this is not gonna work. What even goes on to parse tokens? Numbers, identifiers, and ops. Okay, well, sure. Ah, crap. That makes a mess. Okay. But that's fine, actually. I think we can definitely do something with that still. We just need to handle things differently, at least. I don't really know what I'm gonna do with that, though. Let me think. We should probably like store a tree structure on this at least, if it's like parse as we go. especially if it's like bottom up. Yeah, I think that might be worthwhile. So let's give this a try. We might need a new structure for this though, I fear. So we need to go to AST, I think. We need a new type here, which is an expression. And that's not gonna be enjoyable. But then we can flatten that out in HIR, I think. So that will be kind of alright, at least. Yeah, I think I should make this a separate file. Or wait, what am I doing? Okay, let's do that. Yeah, let's make this header. This definitely needs to include Atom. We can steal a lot of the stuff from here. We need this. We need some of this, I think. I don't think we need type. Yeah, I don't think we need type here. Because everything right now is just one type, but I imagine it could get complex really quickly. Yeah, so let's paste this here. I think we're gonna need all of this. Yeah, so this also gets a AST on it. Right? Yeah, okay. Oh boy. I could also just have the... Alternatively, I could parse precedence just in here instead of in the parser directly. That's the easy way. Let's not do it that way. Okay. Let's make a... Let's make a class expr. And then we want a... and a unary op expr. And we want a binary op expr. Yeah, that will make things easier, I hope. And then if we once we handle like an equals case, I think we can just do that directly instead of something crazy, insane, batshit hell, I guess. Okay. Yeah, what is an expr? Okay, so these all extend expr. Or these are all exprs. Oh. I'm like already regretting this by the second, but I don't know. No gain. No pain, no gain. So that's fair. Okay. What am I doing here? I think we also want a class terminal expr. Yeah, okay. And then this one will just wrap a either a number and an identifier. So just an atom, I guess. So we want like unique footer to atom. And this is val, I guess? Or it's like val, I guess. Yeah, we can just do that. I don't know. Yeah, we can start with this at least for now, and then we can add the methods as we go. So an expr, I guess we can't really define anything there field-wise. Unary we want so we want a unique pointer to terminal, or just expr straight up, I think. Or no, if it's unary I think it's just terminal. Right? Or just expr. We can enforce through build, I guess. And then we need the op as well. Yeah, because we can chain unary ops at least is the other thing. What kind of code are you writing here? It's all C++. We need operator. Oh, we need to update operator. Oh no. Okay. Let's see. We have our big sheet here. Okay, so we have this, we have call. Oh wait, no, we need a unary op as well, I think. That's what I'm missing. Enum class unary op. So we need call, we need plus, minus, not, or logical not, need bitwise not. We don't need these yet, actually. We'll add them later. I keep saying that, but like unironically we'll just add them later. We just need this to exist for now. This needs to be unary op. So a plus. This is a unary op add or plus. Is your scanning and parsing done by hand? No. I'm using a parser generator because I don't want to write it by hand, I guess. That's the short answer. Oh, this is not ideal, actually. I think. Actually, no, this is fine. Yeah, this will... I don't think we need that for call, at least. I'll implement that one later. I'm scared. Which generator? Pectool. I'm making such a mess here. What task are you trying to do? I'm trying to write a compiler from at least some subset of C to x86-64, but as I'm finding, there's a lot of design decisions that I need to make by hand, which I'm not good at yet, at least. Good luck, thank you. Are you a CS student? Yes. Okay, we need to change these out. This is so awful. Maybe I'll just make call its own thing actually. I think that would be useful. Because it's not really a unary op, I guess. Like it is, but also like not really. Yeah, we need to handle. Yeah, maybe I should just get rid of. Maybe I should get rid of that in here. It just doesn't really fit, at least. Yeah, I'm gonna get rid of call. And it's just gonna be its own thing, at least. Yes, we need this, and then we need unary op, I guess. I'm gonna do that. So we want this should just be a unique putter. To Atom X literal. This is a Kali, I guess. To do params, because this will always be the forever meme, I guess. Yeah, let's put this below here at least. Okay. So that makes sense. We can kind of steal this here as well, I think. Binary op instead though. And then this is left, and then we can make a right as well. Okay. Oh boy. Warnings, that's fine. We aren't gonna use vector for now, I think. We will eventually though. Type, I don't think we need to look at. This is just the expression. Yeah, this is like low-key kind of difficult, but that's why I'm here at least. Let me just make a note for this. Unary op. Okay. We have that now. Expert.h has a start. We need to implement most of this now in some fashion. I think these need constructors that are meaningful, so we need to do that as well. Unique putter of type atom. Yeah, we can do that. that here. Call expr. This is a atom literal. Call e. I keep trying to make everything control flow graph, just like mentally, because I'm still in middle on land. I haven't like thought about the front end in a while. God damn. Yeah, why didn't I just start with this? This was really troll for me to not start with at least. I don't know what's going on, but I love watching the streams. Thank you. If there's anything you're ever curious about, just let me know, and I'll explain it to the best of my ability. Wish I was at this level. I definitely have a lot to learn. I think, at least where I'm at right now, is definitely something that anyone can attain, to be honest. It's just hours at the end of the day. And then the next thing is just binary up here. I see some of that's cut off. Let me just do that. Paste that. This is left now. Okay, cool. So we at least have constructors now. I'll figure out what to do with these at some point, but you know, we'll take that as we go. I also just realized I might need a visitor of some sort for this. We're not even actually. We're not even running a lot on this. It's just code gen. So we can just give it a visitor, and then we can recursively descend, I guess. Okay, so let's steal all of this. Okay. Oh, we don't need that. This one is just atom is the move atom. What's wrong here? Oh, whoops. We have AST, expr H. Okay, don't need that. Can get rid of a lot of these. This is very boilerplate. Oh. There we go. And we can get rid of that. Op is op, and then value is the move value. This is just very boilerplate, which it is what it is, I guess. This is always how writing objects is, I guess. Calc 2 is giving me a battle right now, but I'm doing good in GSA. Yeah, that sounds pretty good. I guess like I'm trying to think when the last time I like literally took a derivative was, and I think it might have actually just been in multivariable calc. So, I guess the good news is that doesn't really affect much in coding land, I guess. Unless you're doing like machine learning, in which case, well, you might have to deal with some gradients, I fear. But even still, I feel like it's mostly linear algebra, more linear algebra than calc in general. So, I guess if you're doing like physics stuff, then maybe. Yeah, I don't know. That's just my 2 cents at least. All of these are implemented. We can at least start creating expers now, I think, which is scary. Let's make some commits real quick. Oh, god damn it. Okay, yeah, fair enough. Operator. Add some unary operators. AST. And then okay. Alright, we've got our checkpoints made now. Yippee. Okay, so this obviously breaks still. I don't even know how to begin to parse any of this anymore. Yeah, okay. What to do? I guess we could just make a... wait. Yeah, I think parse tokens is fine. Maybe we can get rid of binary ops from here. We can just handle those directly, actually. We're just gonna be like making a shit ton of, I guess, actions, but that's fine. That's to be expected. Yeah, so we can get rid of that. We don't have pop bin op anymore. Yeah, so these are fine still, I think. Pop identifier pop instruction is fine. Yeah, so we can do that at least. I think that's useful, and then we should std vector of what do we call this? Exper, I guess. Parsed expers. Oh yeah, we need to include exper. Alright, we are making a mess. Unique pointer. Because we will need the unique pointer. There we go. Okay. Yeah, this doesn't exist anymore. A lot of other things are definitely broken now. Okay, let me actually just take a second to look through this again. So scope, we need to handle this, I guess. So we still have declaration. This is just declaration assign now. This is just assign. This doesn't exist anymore. Return still exists, but we do something different. I'm just gonna fix that as we go. Call doesn't exist, and call assign doesn't exist anymore, which is crazy. And then the rest still exists, which is fine and dandy. We need to add instruction exper as well, I think. that's the last one that we're missing. I think I could put this towards the top though. Yeah, this template stuff is kind of insane. Yeah, we're just gonna steal this line here. We're just gonna to-do this as well, because I don't really want to do that yet. Okay. Okay, so at least everything exists now, which is handy. Oh god. There's so much to do. There's so much to do. The big one is we need to, I guess, make expers. Okay. Yeah, where do I even go here? I guess I would have to start making things for each of these, which is gonna be annoying. So maybe on second thought, I actually simplify this a little bit. Yeah, let's simplify this down. Title SOR. This is either asterisk or a slash. This is one thing now. We can definitely clean this up as well. Is it a plus or a minus? I'll just call it unary, I guess. Okay. We'll figure out those two later. I guess all of these tiers are kind of small from this point though, right? Yeah, because there's just like a couple of unary operators here that we care about. We can definitely make this a little more compact. Right? I guess some things we will have to make a mess with. Let's make this add subtract, I guess. Make this a structured or sequential or I don't remember what it is. Yeah, that parses fine. This is now a add subtract. Yeah, these I think we just have to make do with, which is really funny, because we need to preserve parsing order. Yeah, and then the rest of this is fine. Okay. So I think we want to write an action for bitwise, or like each of these sub actions, I guess. Oh wait, no, we should separate them up because they all have different behavior and we can just hardcode things. Yeah, I like that more, actually. Alright, we're already going back on design decisions this soon in. Okay. Yeah. So the idea here is we can call this to like, I guess we don't even need to call expr 3 then, right? Yeah, we just need to call, that just matters for like parse order. We can just directly call these, I think. And how do we structure them? These ones are still fine. We just create a token, I guess. I guess like value as well. Expr 1, at the expr 1 level, if we parse a call, yeah, we can just create that, I guess. We can just take the back identifier and we can push that on. And then down here, we can kind of just keep doing the same thing. Again, we don't need an action for like any of the expr underscore whatevers. I think it's just like the specific ones that we call within that. And then that will just make a new expr object each time, I think. What made you want to use westterm? When I initially started doing like NeoVim related stuff, I didn't want to install Linux. So I was like, okay, we're just gonna use WSL. And then I Googled literally like, what is the best terminal WSL support? And westterm just ubiquitously came up #1. But after using westterm for a while, I've definitely grown to appreciate the fact that it's all Lua configurable at least. It feels very seamless when I'm just in configuration mode, and I can sort of zip back and forth between like westterm stuff and like NeoVim stuff, and it's just all very seamless, it feels like for me. Yeah, I don't really want to implement this right now. I'm kind of tired. It's been 2 hours. What do I change here? Fix. Get rid of compile errors. Still need actions. Origin. Pure parsing. Okay. One more thing before I go, I want to, I guess, set things up for next stream. Usually I do this off stream, so I guess this is a little bit of like behind the scenes work. Yeah, so I'm sort of setting up the list for next time at least. Let's just like add a couple lines there. Okay. So what do we want to do here? Or what's like the sequencing for stuff we want to get done? We want to implement actions for finish actions. Then we want to make exprs printable, debug exprs, I think. And then I think we need to fix HIR at some point, I think. We don't need to fix MIR though, because that's kind of all compartmentalized off at least. HIR is like the less substantive layer I think we need to change something with. But even still, I think we can kind of leave it mostly as is. We just need to add more operators. Yeah, so we need to fix HIR, and then we can debug, because I know I'm going to have done something wrong. And then we can add more exprs. Yeah, and then I think that's mostly it. Yeah, I think that's like the big pile. Next time, I think these two are going to be my big focus. So I'm going to throw these down here. Yeah. Anyway. Are we pushed? We're pushed. Okay. I think that's a good place to call the stream today. thank you all so much for being here and for, I guess, sticking around, even though I low-key started stream a little bit late today. I like got back to my room, ate food, and then like passed out for a solid hour. Yeah, modern college life. Yeah, make sure you sub to my channel if you haven't, and like the stream. It really helps out with the algorithm, and it helps push my content out to more people like you all. Especially for like getting my stuff shown up on the recommended page. While you're down there, if you haven't already, make sure you join my Discord. There's a nice little channel where you can get pinged when I go live. That's the best place to get notified when I go live because YouTube is a little bit finicky with that. It's also the best place to chat with other people in my community and sort of just get to know everyone a little bit better. And of course, make sure you add me on GitHub and connect with me on LinkedIn to stay up to date with what I'm doing and, I guess, have me in your books. And the final thing, I haven't said this in a while, so I may as well. If you know anyone that's at a firm that's looking for a compiler intern, send my info their way, or give me a referral. It would mean the world to me. As always, yeah, I'm gonna go get food now. I'm a little bit hungry. Yeah, take care, y'all. Take it easy, and have a wonderful rest of your day.